Okay, hello folks. What I'm going to do is do a video of me solving these problems because some of them are kind of tricky. I'm also just going to post the solutions as if I gave them to you on paper, but some of you might find this helpful. All right, first question. You kick a soccer ball from the ground into the air. The path of the ball is given by this equation, so it's a parabola because it's squared, and negative a value, so that means it's upside down, and that checks out if you're kicking a ball. H is the height of the ball. So h is the height of the ball above a nearby building. Okay, so the first question says, how many seconds does it take for the ball to reach the height of the nearby building? Well, if h is the height above the building, and we just want it to reach the building, so be at the same level, then we want our height to be 0, which is the same height as the building. And if you look at this equation, you can actually figure out very quickly the height of the building. So think about it, times 0, put a 0 here and a 0 here, what's the height? Well, at times 0, these would cancel out and the height would be negative 20, which means at the beginning, our height is negative 20 meters above the building. And if we're negative 20 above the building, we're actually 20 below. So for this question, though, we want to set h as 0 because that's when the height's going to be the same as the building. Because if it's 0 meters above the building, that means it's at the same height. And now we're going to solve this. So in grade 9, if I gave you this, 3x plus 2 equals 7, and I said solve for x, you'd subtract 2 and divide by 3. But in grade 10 and 11 and 12 and so forth, if I ask you to solve a quadratic, you can't just rearrange because you've got two different t's. So that's why factoring becomes necessary. So to factor this, first I'm going to pull out that common factor, minus 7t and then plus 10. Okay, and then I'm going to factor what's in brackets, and I get t minus 2 and t minus 5. So that means my answer are t equals 2 and 5. So this means that after 2 seconds and 5 seconds, the ball is at the same height as the building. And that's it. That's how you do that. Okay, part B. What is the maximum height of the soccer ball? So to find the maximum height, we want to find the vertex. And if we're going to find the vertex, step 1 is find the axis of symmetry. And to find the axis of symmetry, we take the zeros, which are 2 and 5, we add them, and we divide by 2. So I get 3.5. And then 2, to get the y value, we have y equals. And we can use the factored form, or we can use the original form. So it shouldn't be y, it should be h. And this x should have been a t, I suppose. It doesn't really matter that much, but there you go. It's t now. I don't like that a t. So h equals negative 2, and then I put in my t value there, so 3.5. I'm using the factored form, because remember, if done correctly, the factored form will actually show us whether we're correct or not. So h equals negative 2 times 1.5 times negative 1.5, so that checks out. Okay, 2 times 1.5 times 1.5 is 4.5. So h equals 4.5. So max height is 4.5 meters above the building. So now my question for you is, how high off the ground was that? If we get 4.5 meters, how high off the ground is that? Because that's how high it is above the building, right? The answer is 24.5 off the ground. Okay? How many seconds does it take for the ball to reach its highest point? Oh, we just got that, right? T equals 3.5 seconds. That's the axis of symmetry. Part D, how tall is, 20 meters. So you can see these last questions we already answered by the time we got here. Okay. Let's go to Desmos. Okay, so I have graphed the parabola here. So let's take a look. So we can see the initial value here is right here, negative 20. The max height is 3.5, 4.5. But if you look from here all the way up, that means it went 24.5 meters off the ground. Either answer would be fine. 24.5 meters off the ground or 4.5 meters above the building. The zeros are 2 and 5, or in this case, what that means is that it reached the height of the building. So what you can actually do is, let me show you sort of what this looks like here. I'm going to bring this way up to here. Okay, so you can imagine this. This is the ground. Okay, and this said negative 20 here. And then we can draw the building. So let's say the building's like this. Building. So there's the building. The ball goes up and over the building and back down. Cool? All right. Next question. Mark looks at this equation. He says its zeros are negative 4 and 5. It opens down and it's really skinny. Do you agree? Well, definitely disagree. The zeros have the wrong signs. They are positive 4 and negative 5. It opens up because A is positive. And finally, it's actually fatter than the basic parabola because A is 0.5 and it has been compressed. All right, so now Laney or Lane or whatever says, she looks at this equation, negative 3x plus 4 squared minus 9. She says she knows this parabola doesn't have any zeros. Do you agree or disagree? Well, the best way to approach this is to do a little sketch. Whoa. So, the vertex is negative 4, negative 9. So let's say it's there. And does this open up or down? It opens down. And there it is. So, does it ever cross the x-axis? Does it have zeros? It does not. I agree. The vertex is below the x-axis. K is negative 9. And it opens down. Sound. A is negative 3. So, it never crosses the x-axis. Complete the table. All right. So, by writing the equation of each parabola, we're given vertices. So I would assume we're looking for a vertex form here. So the step pattern is 2, 6, 10. This essentially, the first one tells us A. So 2, x minus 0 squared minus 18. And then here we have y equals negative 3, x minus 11 squared plus 12. Of course, in this one here, we could have just written y equals 2 x squared minus 18. And that's the preferred answer, because x minus 0 is just x. And the descriptions of the transformations. So here we can say shifted down 18 units and vertically stretched by a factor of 2. Let me steal this just for the font size. This one's going to be shifted right 11 and up 12. Reflected about x-axis because A is negative, and then vertically stretched by a factor of 3. Okay, I lost it in that little box. Next part is to describe how to graph this. So for this one, step 1, plot vertex at 5, negative 2. Step 2, go over 1, down. So remember, our basic step pattern is 1, 3, 5. In this case, A is 0.5 or 1/2, so we don't go down, we go up. Over 1 up, 0.5. Over 1 up 3, over 1 up 5. And I'm going to change the word over to right. And you'll see why in a second. Okay. And obviously, these steps aren't correct here. So right 1 up 0.5. Right 1 up, this is going to be 1.5 because I got to multiply 3 by 1/2. And then finally, up 2.5. Okay. And then step 3, I'm going to say reflect the points from step 2 over the axis of symmetry, which is x equals 5, onto the left side. So we went right from the vertex, now we flip all those points over to the left. Okay, next one. Step 1, plot vertex at -1, 1. Step 2, go right 1. The A value is -1 there. We just see a negative sign, but that means it's -1. So that means we're going down. Right 1, down 1. Right 1, down 3. Right 1, down 5. Okay, and then I'm going to steal this because it's the same pretty much. Reflect the points from step 2 over the axis of symmetry, which in this case is x equals -1, onto the left-hand side. And then I could say draw a curve through them, but that's pretty basic. All right, number 3, or part C. Plot vertex at 7, 9. Go right 1 down 3 this time. Right 1 down 9. Right 1 down 15. And reflect it over the axis of symmetry, which in this case is x equals 7. Okay. Again, you can ask questions. We'll have a help session Thursday at 1 p.m., so please feel free to come. Next one, a dance club has a $5 cover charge, 300 customers. Over the past several months, they've changed the cover price several times. For every increase of 50 cents, so here's the key, the number of customers decreases. So, first thing, let x represent the number of 50-cent price increases. And now we have our revenue function equals number sold times cost per. And so in this case, I'm changing revenue to R to save space. Number sold. Originally, they sold 300. For every 50-cent increase, the customers go down by 30. It's minus 30x. The cost per starts at $5, and it goes up by 50 cents each time they raise the price. Okay, so there we go. Now we're asked to write it in vertex form. Okay, so let me steal this. Right down here. So if we want it in vertex form, the first thing we need are the zeros. So from here, 300 minus 30x, we set it equal to 0, and now we solve. So I subtract 300 from both sides. I get negative 30x is negative 300. I divide by 30, and I get x equals 10. And then from this one, 5 plus 0.50x equals 0. I subtract 5 from both sides, and I get 0.50x equals negative 5. And then I do negative 5 divided by 0.5. So negative 5 divided by 0.5 is probably like negative 10. It's negative 10. Okay. So those are my zeros for this function. So if they charge, so 10 50-cent increases, So that's an extra $5. So if they charge $10, then they make nothing. Presumably no one comes, I guess. If they charge $0, so if they change the price, if they increase it negative 10 times or they decrease it 10 times, then that's going to make this equal to 0. Right? So if you put in 10 here, this is the number sold, it goes to 0. If you put in negative 10 here and figure out what this would be, the cost goes to 0. So if no one comes, they make nothing. And if they don't charge any money, they make nothing. Okay, so now to find the vertex, we need the axis of symmetry. And we're going to add the zeros, divide by 2, and we get 0. And now, to get the max revenue, we are going to sub in the axis of symmetry into the equation that I have above. Okay, so this is going to be, well, 30 times 0 is 0, so this is 30 times 5, and the revenue is 150. Okay, so this says $5 cover charge, 300 customers on Friday night. Blah, blah, blah. Oh, I'm sure you picked up on what I did. I looked at the answer and I'm like, $150, that's crazy. I just made a silly mistake, as I often do. This is 300, right? It was 300 here, all good. And then down here, I put 30. So that should have been 300. So let's change that to 300. So 300, 300. And 1500 is now our answer, which makes a little more sense. Let's graph it in Desmos and see. Okay, so here it is. We can't see anything. Oh, there's the zeros at 10, negative 10 and 15. Well, that's not what I got. I wonder if I wrote the thing wrong. I did. It was minus 30x. All right, there we go. 10 and negative 10. And if I squish it down, there it is. My max revenue is $1,500. And the question remains, I suppose, how many price increases was that? Well, we got the axis of symmetry, or the x value, to be 0. So basically that tells us that they should never change the price. As soon as they start changing the price, they lose money. Okay? So the question actually asked for the vertex form. So let's do that now. The vertex is 0, 1500. But we don't have our a value yet. So how do we get our a value? Well, there's a few options. One option is this. Y equals a, x minus 0 squared plus 1500. And then we take a point. Let's say take this point here. When x equals 10, remember y was 0. So 0 equals a, x is 10 minus 0 squared plus 1500. I subtract 1500 from both sides. 10 minus 0 is 10, squared is 100, equals a times 100. And I divide on both sides, and I get a equals, I'm going to say negative 15. I think I did that correctly. There's a way we can check that, though. So this would mean our answer would be revenue equals negative 15, x minus 0 squared. So that would just be x squared, and then plus 1500, I guess. Okay. So I guess that would be the same. And that's kind of weird. That just looks like standard form, doesn't it? That's strange. So let's go back to the Desmos here. I guess the other Desmos. And let's try this. Let's go negative 15. Was it negative 15? Yeah, negative 15 x squared plus 1500. Ha! It's the same! But, okay, so let's put it in vertex form. X minus 0 Oh, it's still the same. Well, that's weird. So what you should get out of this is that when we haven't moved the parabola left or right, so when the x value of the vertex hasn't changed, vertex form is actually the same as standard form. And now another way that you could have gotten the a value is to take the original equation. So r equals 300 minus 30x times 5 plus 0.50x, and FOIL it out. So r equals 1500 plus 150x minus 150x minus 15x squared. Let's rearrange it and collect like terms. So the 150 and negative 150 cancel out. So I get negative 15x squared plus 1500. So from here, I can see my a value is negative 15. This is the first value. And this is actually the exact same equation we got. So remember, you could also say here, or r equals negative 15 x minus 0 squared plus 1500. I'm going to put an important little note here. When the x value of the vertex, or h, is 0, standard and vertex form are the same. Cool. Okay, so there's that. I'm going to put this on a separate page. Because it's a big question. And I think that's it. Okay, folks. So there are task A, B, C, and D done for you. I know it looked like I didn't know what I was doing here with this one. I was just kind of trying to make the point that vertex and standard form are actually different most of the time. But when the x value of the vertex is 0, they end up being the same, which is kind of cool. So that's it. So you've got the weekend to study. I'll put a little more review out on Monday, and then the test will come out Tuesday.